Okay, so let's look at the idea of combustion now. And so combustion happens when we react an alkane molecule with oxygen. And not just an alkane molecule, combustion also happens with alkenes. And if I talk about the products, so this is your general equation. And the products for combustion are CO2 plus water. And the thing that we need to remember here is that this oxygen is going to be in excess. What does this mean? That the oxygen is going to be in a very large quantity, or in terms of favor, they're going to say that okay, oxygen, the reaction is happening in the air. So by that you can assume the oxygen is in excess, and this is going to be something that we call as the complete combustion. And yes, combustion has two types. One is the complete combustion, and the other is the incomplete combustion. And we'll talk about that as well. So this is the complete combustion, and you know that oxygen is going to be in excess. And if I talk about incomplete combustion, I think let's first take an example for an alkene. So let's say I talk about CH4 plus O2, CO2 plus H2O. So this is an unbalanced equation. This equation is not balanced here, but it's a chemical equation for a complete combustion of an alkane molecule. Now let's talk about incomplete combustion. So in incomplete combustion, the only thing that you guys need to remember is that the products of this equation are going to be different. And what are those products going to be? So you are going to have carbon monoxide, you're going to have carbon and water. Okay, and this is all what you need to know about the incomplete combustion. They won't ask you to write the equation for this, and they won't ask you to make reaction equations with different alkenes. This is the only thing that you guys need to remember with incomplete combustion. Okay, but we do need to look at what? We do need to look at the reaction of different alkenes with oxygen. Okay, so let's take methane first. So when methane reacts with oxygen, it forms carbon dioxide plus water. So the equation is simple, but again, what's the catch here? This equation is an unbalanced equation, and you have to balance it out. So how do we balance it out? So even for balancing, we have a general equation. And what does this look like? So the general equation for balancing looks something like this. So you have Cx Hy plus y over 4 plus x. And in the products you have x CO2 plus y over 2 H2O. And I'll explain how does this work. So let's say we have how many carbons? You can see that we only have one carbon here. Okay, so what we have to do, we have to make both sides equal. So for this particular alkane molecule, we're going to be comparing this with the carbon dioxide. Okay, so here the value of carbon is 1. So we can say the value of x is equals to 1. So if the value of x is equals to 1 here, that means the value of x here is also going to be what? Also going to be 1. So we can place a 1 here. Make sense? Okay. Then you have got hydrogens. So hydrogens are here 4, and the value for y we can say will be 4. So this is y is equals to 4. And to figure this out, what we will do now with this hydrogen, we'll figure out the moles of water. How? It says y over 2. So we'll divide 4 divided by 2 because the value of y was 4, and this comes as 2 H2O. So we are going to be placing what? A 2 in place of H2O. Now if you look at the equation, we have 1 carbon on the left and 1 carbon on the right. Then we have 4 hydrogens on the left, and we have 2 multiplied by 2, 4 hydrogens on the left. Now the only thing that we need to figure out here are the oxygens. Let's have a look at that. So how many oxygens are there on the right? So you have 2 oxygens here and you have 2 oxygens here. So you have a total of 4 oxygens. Okay, what is the formula? The formula is y over 4 plus x. And you already have the value of y and x. So what you're going to do is to simply place the values, plug in the values. So y is 4. So this is 4 over 4 and the value of x is equals to 1. So this is 1. And you'll take the LCM. This is going to come as 4 plus 4 multiplied by 1 and this comes as 8 over 4. So this is 4 and 4 and this is 2. So the value of oxygens that you need is 2. So you are going to place 2 oxygens here and this way you also have 4 oxygens. And now your chemical equation is completely balanced. Okay, let's look at a example so that you understand this completely. Let's look at C2H4, O2, and the products are CO2 plus H2O. What is the general equation? Let's also write down the general equation here so that we remember. So this is y over 4 plus x, and the products are XCO2 plus y over 2 H2O. Okay, alright. So the value of x here is 2. The value of x is 2 and the value of y is 4. Okay, so what can we do? So since the value of x is 2, this means the value of carbon here is also going to be what? 2, because this is also the x here, this is also the x here, the value is going to be the same. So this is 2CO2 and this comes as 2 carbons on the right and 2 carbons on the left. Okay, I said it the opposite way. Okay, but 2 carbons on the left and 2 carbons on the right. Now we need to see the hydrogens. So hydrogens on the left are 4 hydrogens on the left. Let me just put the symbols as well. So there are 4 hydrogens on the left. And how will we define this? So we know the formula is y over 2. So the value of y is 4 and it comes as 2. Okay, I think we have made a mistake. The value of H here is equals to 6. Why? Because the alkane molecules is C2H6, not C2H5. Sorry, H4. So this here is 6. Sorry, this here is 6. So 2 and this comes as 3. So the value of Y is 3. Okay, so now this comes as 3. So now you have how many hydrogens? You have 6 hydrogens here and you have 6 hydrogens here. Okay, let me just make this a bit clean. So you have this and this one and this one. Alright. 6 and 6. Okay, so this is now balanced. What remains? Now the only thing that we need to balance are the oxygens. So we'll see how many oxygens are there on the left. So you have 3 oxygens here and you have 2 multiplied by 2, 4 oxygens here. So that means a total of 7 oxygens are present here. Now what is the formula? The formula is y over 4 plus x. The value of y is 6 divided by 4 plus 2. And we'll take the LCM here, which is 4, 6 plus 4 into 2. And you'll have 4 multiplied by 2 is 8 plus 6 is 14. So 14 over 4. So this comes as 2 and 7. So the answer comes as 7 over 2. So you will write here, at this place you will write 7 over 2. So the equation comes as, if I write down the complete equation now, which is C2H6 plus 7 over 2 O2 and 2 CO2 plus 3 H2O. Now the problem here is that you have a value which is in fraction. You could also write this in decimal like 3.5, but the most preferable thing in the CIE is that you write in the whole numbers. So what can you do to bring this whole equation or this value into a whole number? It's simple. you'll just multiply the whole equation by 2. So what's going to happen? This 2 multiplied, this 2 here gets multiplied here and gets cut down. And so you have a 7O2 remaining plus, so this 2 now also gets multiplied here with this carbon. So this comes as 2C2H6, and then this 2 also gets multiplied here, which makes it 4CO2 plus, and this also gets multiplied here, so this comes as 6H2O. And this is your final and full balanced equation. And you're very welcome to count. It is going to come as the same number. All right, let's look at one more example. Let's look for a bigger number. Let's say we talk about C4H10. Okay, so C4H10 reacts with oxygen and forms CO2 plus water. Okay, we already know the general formula or the general equation. Now we'll solve this directly. So since there are the atoms of carbon are 4, we know that X is equals to 4 and Y is equals to 10. So here we'll directly just place a 4 because this is also a place of X. Now here, to figure out this mole, the moles of water, what we will do is divide the value of 10 by 2. This is what we did in the previous part as well. So this comes as 5. So now your equation becomes, you have 4 carbons on the left and you have 4 carbons on the right. You have 10 hydrogens on the left, and now you have 5 multiplied by 2, 10 hydrogens on the right. The only thing that's remaining here are the oxygens. How do we figure that out? So the value of Y is 10 divided by 4 plus the value of X is 4. And the formula that we are following here is Y over 4 plus X. Okay, so this comes as 10 plus 4 into 4, and this comes as 26 over 4. So the value here comes as 2 into 13. So this is 13 over 2. 13 divided by 2. What we will do, we'll write it the same way. C4H10 plus 13O2. You have 4CO2 plus 5H2O. Again, we have the same problem. What is the problem? We have a fractional value. And to reduce the fractional value, what we are going to do is to simply multiply the whole equation with 2. So what is going to be your answer now? 2C4H10 plus this and this gets cancelled. 13O2, and what's happening with the rest? This 2 is cancelling this 2, and this 2 is also getting multiplied by with these individual whole numbers at the start. Okay, so here you have 1, so answer comes as 2. Here you have 4, so answer comes as 8. And here you have 5, so the answer comes as 10H2O. So this is your final equation. So let's look at one more example. So let's talk about C6 and how many hydrogens C6 is going to have. So it's going to be C6H14. C6H14, right? So C6H14, this is going to be a hexane molecule, by the way. So write down the equation C6H14 plus O2, and you have CO2 plus H2O. Now the value of X is equals to 6 and the value of Y is equals to 14. So you already know that there is going to be a 6 here and there is going to be a 7 here. How? You divided by 2 and you wrote the same value here. Wrote the same value here. You divided the value of Y by 2, and the answer you get is 7. Okay. What do we need to figure it out? We need to figure out the oxygens now. So the formula for that is Y over 4 plus X. The value of Y is 14 plus 4 and the value of X is 6. So this comes as 14 plus 4 into 6 plus 4, and this comes as 24 plus 14, that comes as 38 over 4. 2 into 19. So the answer comes as 19 over 2. We'll do the same thing. We'll put 19 over 2 here, and to remove this fraction, we'll multiply the whole thing by 2. So this comes as 2C6H14 plus 19O2 and 12CO2 plus 14H2O. And this is how you write equations for the combustion reactions of all alkenes. Okay, understood? Bye.